Hello everybody, welcome to topic number 10, graphing linear inequalities. In this video, we're going to show you how to graph linear inequalities on a coordinate plane, as well as graphing the intersection or union of two linear inequalities. So in this lesson, we're really going to merge and combine two of the ideas that we've done before. We've taken you through how to go through and graph equations, but now we're going to do the same thing with inequalities. So a lot of our graphing rules will still exist. We'll remind you that when we go through and we try to graph things, we always like to put it in the form y equals mx plus b, where m is our slope that tells us how we move, and b is our y-intercept. We're still going to start at our y-intercept, and we're going to move using the slope. That has not changed. The only thing that's changed now is instead of an equal, it's going to have an inequality sign. It's going to have either the less than or the greater than, or the less than, an equal to, or greater than or equal to. We'll have to go back and remember when we go through and we did this on a number line. We remembered that parentheses we used for less than or greater than, or brackets we used for less than or equal to, or greater than or equal to. But now we're talking about a coordinate plane, so we need something similar as we go through and do that. And there's two things that are going to help us with this. The first thing is that the type of line. When we go through and graph, we're either going to have two types of lines. One of them is the line that we've worked with the most, graphing a solid line. The other is now we could have a dotted line. How do we know when we use which? It all depends on the inequality. If your inequality has an equal sign under it, you will use a solid line. If your inequality does not, then you will use a dotted line. We're also going to have to shade our values, just like we did on the number line. Remember, on the number line, we shaded either left or right, depending on what sign it was. But now when we shade in a graph, we're going to look at it as shading above the graph, meaning we have a line and we're shading above it, or shading below it. We have a line and we need to shade below it. And again, this all is going to depend upon the sign, and this one should make sense. Above, where all the numbers are getting bigger. So anytime you have an inequality sign that has a greater than, we will shade above. If our inequality sign is a less than, we will shade below. So everything has its own different combination. Some of the lines will be solid and dotted, depending on if it has the equal sign or not. And we're going to shade above or below when we go through and we do it just based on the sign. Other than that, we're going to graph them just like lines when we do this. Let's test this out. Let's start with b. Y is greater than or equal to x plus 2. So think of this in terms of y equals mx plus b. The 2 is my y-intercept. That's where we're going to start. So we're going to start at the origin, and we're going to start 2 up. Here's my first point. The 1 is the slope. So this is really 1 over 1, which means we'll go up 1 and to the right 1 from this point. So from this point, up 1 and to the right 1, and we've got our dotted lines. Now if we were doing an equation, we would draw a line through it, and that would be the end. But now we have to take a look at the sign and see how we're going to finish graphing this. So when I have greater than or equal to, that means two things. The equal sign means I need a solid line. So I'm going to take this line, and I'm going to draw it as a solid line through the points. The greater than sign also means I need to shade above. So when I go through and I shade my answer, I'm saying that anything above this line and the line will be my answer. So when you go through and you do this on My Math Lab, you'll graph the line, making sure it's a dotted line, and then we'll shade the region above it. And again, if I picked any coordinate in that above region, it would work in here. If I picked anything below, it shouldn't. For example, let's go through and pick this coordinate, which we know is the origin, 0, 0. If I plugged in 0, 0, I would get 0 is greater than 0 plus 2. Well, 0 plus 2 is 2. Is 0 greater than or equal to 2? No, that's false. So we can see clearly that doesn't work, which is why it's unshaded. But let's say I picked 0 and 4. So this coordinate right here is 0, 4. Let's try it with 0, 4. 4 is greater than or equal to 0 plus 2. 4 is greater than or equal to 2, which is true. So everything in the shaded region represents a true answer that works in the equation. Everything in the unshaded region represents something that doesn't work. As well, everything on the solid line works. That's why it's solid. If it was dotted, that would mean it did not work. Let's go back and do A. Y is less than x. So in this case, we don't have anything being added or subtracted to it, so we can pretend like that's really a 0 there. That will end up being my y-intercept. So we're going to start our graph at the origin. Our slope, again, is x, which is really just 1. And we can turn that into a fraction by going 1 over 1. So I'll go up 1 and to the right 1 from the origin. Up 1 to the right 1. There's my dot. Now let's take a look at the sign. The sign is a less than. Doesn't have an equal sign under it, so it gets a dotted line. So when you go to My Math Lab, you'll have to pick the option that is for a dotted line. And it should look like this. It's also a less than. Well, all the values that are less than 0 are below. So we're going to have to shade below the graph. So I would go through and shade everything below the dotted line. So again, just like we did with the number line, we're shading, but now we're shading above or below the graph. And then we're using a solid or a dotted line depending on, is it an equal or is it a not equal to. Let's do it again with these two. The only thing we'll have to do different with these two is make sure we solve for y, just like we did with regular equations. So if I have x plus 2y is greater than negative 2, in order to get y by itself, I have to subtract x from both sides. 2y is greater than negative x minus 2, and then I'll divide everything by 2. So in this case, y is greater than negative x over 2. Remember, that's really like a 1, so negative 1 over 2x. Negative 2 divided by 2 is negative 1. Now we can graph this. Our y-intercept is negative 1. So I'm going to start 1 below the origin. This is my slope. It tells me I need to move down 1 because it's negative, and to the right 2 from the point that's at the y-intercept. So down 1 and to the right 2. Now let's take a look at the inequality sign. It's a greater than. It doesn't have the equal sign under it, so it's going to get a dotted line. So I will do a dashed dotted line all the way through that graph. And then I have to look and see how I'm going to shade. Greater means we shade above. So I'm going to shade anything that is above the line. And this would be my final answer. Let's do the same thing for the last one. We've got to solve it for y. In order to get y by itself, I have to subtract 2x from both sides. That leaves me with negative y is less than negative 2x plus 6. And now I'm going to divide everything by negative 1. But again, don't forget, I'm dividing by a negative with the inequality. That means I need to flip the sign. Again, when you divide by a negative, make sure you flip the sign. So this becomes y. The less than now becomes greater than. Negative 2 divided by negative 1 is positive 2x. 6 divided by negative 1 is negative 6. Let's graph this. Here's my y-intercept at negative 6. So we will start 1, 2, 3, 4, 5, 6 below the origin. My slope is 2, which we'll call 2 over 1, which means we're going to go up 2 and to the right 1. It's a greater than, so again I need a dotted line because it does not have the equal sign on it. And it is greater, which means I need to shade above the line. So again, when you submit this on My Math Lab, you will submit this graph as your answer, making sure it has a dotted line. Make sure you check sometimes when you're wrong on these questions. It's because we're using the wrong type of line. A dotted line is if our inequality sign doesn't have the line under it. If our inequality sign is just greater than or less than, it gets the dotted line. If it has the line under it, it's greater than or equal to, it gets the solid line. We shade above for a greater sign, and we shade below for a less than sign. We can also graph just the intersection and union of inequalities. Remember when we did compound inequalities, we learned about and or. And, again, as a reminder, is that both have to work. And or means anything that works. We're going to remember this as we go through and graph. So when we're doing a graph, we're going to basically have two inequalities this time. For and, we're essentially going to keep where they both work. So when we go through and graph it, wherever both of the lines work, we're going to keep it. Or, as long as we graph it, we keep it. So anything we shade works. So not much we have to do on or, we just have to make sure any part that works we shade. But for and, we have to look and see where do they both work. And that's the only part we want to keep when we shade this. Other than that, we're going to graph basically two lines on the same coordinate plane as we do this. Let's start with letter A. I've got an and, which means we need to go through and figure out where both work. So what I'm going to do, I'm going to do this in two different colors, and then we'll end up showing you what we would keep on MathLab. The first one is x is greater than or equal to 1. We remember that if it's just x, we have a vertical line. This is a vertical line that goes through 1. So it goes through right here. Again, we have to go through and do the same thing. Is it solid or is it dotted? Because it's got the equal sign underneath it, this would be a solid line. So I would draw a solid line going through here. And then I want all the values greater than 1. So in this case, I would want to keep anything over here. So if I was doing just this problem, this would be my final answer. But now we're going to graph this problem on the same plane, but this time I'm going to do it in red. The y-intercept says start at -1. So I'm going to come down here to 1 below the origin and start there. And my slope is 2 over 1. So I'm going to go up 2 and to the right 1 from that point that was the y-intercept. So up 2 to the right here. Again, I've got a greater than or equal to. So I already know that if that happens, I need a solid line here. And as I create this, you can kind of see we've created 4 little different quadrants with this. It's kind of have this X here. I've got this one piece here. I've got this one piece here. I've got this one piece here. And I've got this one piece here. So I already know that my answer is going to be one of this 1 or 3. Because 2 or 4 didn't get shaded when I did this. This line says I have to shade above the red line. So I'm going to take this and I'm going to shade above the red line. And the only section that I shaded both in was this section number 1 right here. If you look right here, this is the section where I have both red and blue. This would be my final answer on MathLab. I would graph both the lines and I would shade only this section. The section in blue means only this problem worked. The x is greater than or equal to 1. The other one did not work. But again, it's and, so both of them have to work. Section 2 here, the one in red, only this problem worked. The y is greater than or equal to 2x minus 1, not the x is greater than or equal to 1. And number 4, neither of them worked. So again, when I do and, I have to keep basically what we call it's cross-shaded. So it's just that section there that I did in green. Or, like the second problem is easier. Basically, whatever we shade, we're going to keep. Let's take this problem over here and work it and try to get y by itself. I'm going to subtract x from both sides. I have 1/2 y is greater than or equal to negative x minus 4. And in order to get rid of a half here, I need to multiply by 2, which means I need to go through and multiply everything over here by 2. So that leaves me with y is greater than or equal to 2 times negative x is negative 2x. 2 times negative 4 is negative 8. So I'm going to graph this line here in blue. I'm going to start 8 below. 1, 2, 3, 4, 5, 6, 7. We'll call this 8 below. And I'm going to go 2 down and 1 to the right. Now, a little bit interesting here. I can't really go any more down. So another way that we can solve this instead is we can do the opposite. If I can't go any more down because I'm all the way at the bottom, I can go up, but if I go up, then I'm going to go left instead. So in this case, I'm going to go 2 up and 1 to the left and get the same type of answer. It's greater than or equal to. So it's equal, so I need the solid line that goes through it. I will draw a solid line that goes through both points. I'll come back to the shading of this in a second. Next, let's do y is less than or equal to negative 2. So again, if you have y, it's horizontal. And it goes through negative 2. Let's do this one in red. So I'm here at negative 2. I know I'm going to have a horizontal line going through it. It has the equal sign in it. So we're going to go through and put it through like that. Again, we have 4 different regions. Let's number them real quick. We've got kind of this region up here, which we'll call 1, 2, 3, 4. We've essentially made an X. For the first graph, one in blue, I need all the values greater than it. So I need all the values to the top. So I'm going to shade sections 1 and 3. Those are all the values that are greater than it. For the red line, I need all the values less than negative 2. So since it's less than, I need all the values to the bottom. So in this case, I would shade the ones at 3 and 4. Now, if this were an and problem, the only answer I would keep is 3 because it has both red and blue. But this is an or problem, which means this entire graph I can keep. I don't have to change anything. So when I go to MATLAB and grade this, I'm going to make sure those 3 sections are shaded. The only section that won't be shaded is 2 because none of the problems worked within that. So again, an and problem, you have to keep only the section that got shaded with both. For an or, you keep everything when you graph it. Let's try it again with this one. Let's start with the or. And again, or means keep all. 2x minus 3y is less than or equal to negative 2. So I'm going to go through, subtract the 2x from both sides. Negative 3y is less than or equal to negative 2x minus 2. And I'll divide everything by negative 3. Remembering that if I divide by a negative, the sign is going to flip. So y is greater than or equal to, because this was less than or equal to, so we'll call it greater than or equal to. Negative divided by negative, this makes this a positive 2/3 x. Same thing here, a positive 2/3. So let's go through and graph this. 2/3 is a little bit between 0 and 1, so we'll put a point here. From here, we'll go 2 up and 3 to the right. We'll graph our line there. It's a greater than or equal to. Since it's equal, it gets the solid line. And because it's greater, we're going to shade above. And we're going to keep everything we shade. So everything we shade here will be part of our answer. Y is less than or equal to 1. Or I'm sorry, that y is greater than or equal to 1. So again, y is horizontal. So I'm going to go up to 1 And I know it's greater than or equal to, so it gets a solid line at 1 because that's the equal to. And I want all the values greater than it, so I'm going to shade above. So I can already see this part I've already done before, and then this is the new part that I would have here. So again, it's or, so I'm going to keep everything here as my answer. Or is kind of the easier one. Or whatever you shade, you keep as your answer. Let's do one more and one. So again, with the and one, we're going to go through and we're only going to keep what is both shaded. I'm going to do one of the problems in blue and one of the problems in red. X is less than or equal to 3. So it's an X, so this will be a vertical line. And we're going to go over to 3. And we'll draw our vertical line with a solid sign because it's got a line underneath it. So there's the graph of X is less than or equal to 3. Let's quickly graph the other one and show the sections. Y is less than or equal to X minus 2. The y-intercept is negative 2, so I will start 2 down. The slope is 1 over 1, so up 1 to the right 1. And it's got the line underneath, so it is a solid line through. Here is y is less than or equal to x minus 2. Again, if you take a look at it, I've kind of got 4 different regions. I've got one big one here, 2, 3, and 4. I have 2 lines crossing, so they kind of make this x. Going back to the blue line, x is less than or equal to 3. I need all the values that are less than 3. All the values that are less than 3 are to the left of this line. So in this case, I would shade over here. So again, because this is an and, I know I'm not going to keep either 2 or 4 as my answer. What I'm going to keep is depending on the last one. X is less than or equal to x minus 2. So I need all the values less than this, so I need to go to the bottom. So I would shade this way. So which number did I cross shade twice? It should have been section 3 down here. This section 3 that I'm coloring in green right now has both red and blue in it. So when I go through and put it on MATLAB, this should be the only part that is graphed as my answer. The parts in just blue or just red would not be included in your answer. They would be if it were an or problem, but this is an and. So remember, an and, you keep where it is cross-shaded. Once again, or we would keep the entire graph, and we're going to keep where it's cross-shaded. Make sure you practice this a few times on MyMathLab and understand that usually it's the shading that's the problem. So practice your shading and make sure you have the correct line types. Again, if it's a greater than or a less than, you're going to use a dotted line. If it has an equal sign under it, if it's got the greater than and equal to or less than or equal to, then you will use the solid line.